alaikum wa rahmatullahi wa barakatuh. Hi everyone, nice to meet you all. Today, inshallah, we will start to study some examples in mole calculations. At first, this session is very important session for any student in IGCSE because they are mainly used in calculations in quantitative chemistry. Also, if you are in AS level, you will need the following calculations because you will use it in your first chapter, quantitative chemistry. And our ministry students, of course, you will study the same part 2 times. You will study it in our grade and you will study it again in grade 11. So you need to be with me step by step from the beginning and start to listen and understand how we can answer different examples of the calculations of moles and quantitative chemistry calculations. Let's start together. Bismillah ar-Rahman ar-Rahim. At first, we will start to collect the main information about our topic. The main information about quantitative chemistry. If you start to memorize and collect the following data and understand it, it will be easy for you to answer any question in quantitative chemistry. At first, you must know that number of moles and mass of each one mole equals the relative atomic mass AR of its element. Each mass of one mole equals the relative atomic mass of element, or equal the relative molecular mass of our molecule. Or we can say that it's equal to the formula mass of the molecule. The next one, to calculate number of moles N equal mass M over relative atomic mass of element AR or relative molecular mass of compound. So number of moles N equal mass M over relative atomic mass or relative molecular mass. If we have gases in our reaction, the molar volume of any gas equal to 24 decimeter cubic. The molar volume of any gas equal 24 decimeter cubic at room temperature and pressure. So number of moles equal volume divided by molar volume. Number of moles equal volume divided by 24 decimeter cubic. Take care, each 1 decimeter cubic equal 1000 centimeter cubic. Each 1 decimeter cubic equal 1 liter. Next one. Percentage yield or percentage of purity of product. Percentage yield equal actual yield divided by the predicted yield times 100. Percentage purity equal mass of pure product divided by mass of impure product times 100. So percentage yield equal actual yield divided by predicted yield times 100. Percentage purity equal the mass of pure product divided by mass of impure product times 100. Next relation. In any chemical equation, you must have calculated equation or balanced equation. If you don't have balanced equation, don't start any calculation. So you must have balanced equation. Okay? Your balance equals the number of moles. Number of moles is exactly the balance of your equation. And our last information is the concentration C equal number of moles N divided by volume. Concentration is measured by mole per decimeter cubic. So concentration equal number of moles per volume. These information are the main equations used for answering any question in quantitative chemistry. Let's start with the first example. Example number 1, we start with 6 grams of cobalt carbonate. So our mass of cobalt carbonate is 6 grams. Was added to 40 centimeter cubic of hydrochloric acid. So we have volume of hydrochloric acid equal 40 centimeter cubic. Concentration 2 moles per decimeter cubic. So our concentration equal 2 moles per decimeter cubic. Calculate the maximum yield of cobalt chloride, 6 water hydrated cobalt chloride, and show that the cobalt carbonate was in excess. And he starts to give us the equation cobalt carbonate COCO3 plus 2 hydrochloric acid will form COCl2 plus carbon dioxide plus water. Each one molecule of cobalt chloride COCl2 will react with 6 molecules of water to form hydrated cobalt chloride COCl2 6H2O. In the following data, you will find all the data written in black color. They are data given for you in the question. And data are written in red colored. They are the answer of the question. We have some known information and want to calculate the unknown. In the exam, he starts to ask you to solve the question step by step. So just concentrate and know which relation you will use. At most we have 3 or 4 relations. We will use them only. At first, to calculate the maximum yield, the first step, calculate number of moles of hydrochloric acid. For hydrochloric acid, we have volume and concentration. We want to calculate number of moles N. We know that concentration C equal number of moles over volume. So we can say that number of moles equal CV, concentration times volume. And take care, your volume is calculated by centimeter cubic. You must convert it into decimeter cubic. So it equals to number of moles equal CV equal 2 moles per decimeter cubic times our volume is 40 divided by 1000. Why 1000? Because we have centimeter cubic. We must convert it into decimeter cubic. Equal 0.08 mole. Next one. Number of moles of cobalt chloride. We said that number of moles in equation equal to the balance of the equation. In our equation, each 1 mole of cobalt carbonate will react to moles of hydrochloric acid to form 1 mole of cobalt chloride, 1 mole of carbon dioxide, and 1 mole of water. Number of moles of cobalt chloride. So we have 2 moles of hydrochloric acid. Well produced 1 mole of cobalt chloride. Just divide 0.08 by 2. Each 2 moles of hydrochloric acid will react to form 1 mole of cobalt chloride. 0.08 divided by 2 equal 0.04 mole. Next one. Number of moles of cobalt chloride COCl2 6H2O formed equal 0.08 divided by 2 equal 0.04 moles. Okay, just we divide by 2. And in the case of hydrated cobalt chloride, take care. Each 1 mole of cobalt chloride will produce 1 mole of hydrated cobalt chloride. So if we start with 0.04 mole, of course we will have 0.04 moles of hydrated cobalt chloride. Next question. Mass of 1 mole of hydrated cobalt chloride is 238. We can say that relative molecular mass MR of cobalt chloride hydrated is 2038 grams. So maximum yield of cobalt chloride formed. We can calculate the mass of cobalt chloride hydrated formed. We know that number of moles equal mass M over relative molecular mass. We want to calculate mass M. M equal N times MR, number of moles, times relative molecular mass. Number of moles of 0.04 times 238 equal 9.52 grams. Next one. To show that cobalt carbonate is in excess, we want to know which one is the limiting reagent and which one is in excess. He said that we want to show that cobalt carbonate used 6 grams of cobalt carbonate is in excess. In our reaction, we have number of moles of hydrochloric acid of 0.08. And he starts to tell us mass of 1 mole of cobalt carbonate is 119 grams. It is the mass of 1 mole. It is the relative molecular mass of cobalt carbonate. Relative molecular mass of cobalt carbonate is 119. So we want to calculate the number of moles of cobalt carbonate in each 6 grams of cobalt carbonate. Number of moles equal mass over relative molecular mass. We have 6 grams divided by 119, 0.05 mole. We say that each 1 mole of cobalt carbonate will react with 2 moles of hydrochloric acid. Each 0.04 moles of cobalt carbonate will react with 0.08 moles of hydrochloric acid. But exactly, we have 0.05 moles of cobalt carbonate. So we have excess of cobalt carbonate. We want to explain why we have excess of cobalt carbonate. Cobalt carbonate is in excess because each 0.08 mole of hydrochloric acid will react with 0.04 mole of cobalt carbonate. But exactly we add 0.05 moles of cobalt carbonate. So we have excess of cobalt carbonate and our limiting reagent is hydrochloric acid. What is the meaning of limiting reagent? Limiting reagent, it is the reactant which will finish at first. Let's have an example. For example, if we have community. Inside our community, we have males and we have females. We have males and females. In our community, we have 40 males and we have 50 females. To form new families, we will form 40 new families from 40 males and 40 females. So we will have 40 couples. And we will have excess 10 females are single. 10 females are unmarried. So we have 10 are in excess. And our limiting reagent are the males number because they will be finished at first. So our reaction will stop, our forming new families will stop when all of our males are married. Next one. Hydrocarbon are compounds that contains only carbon and hydrogen. 20 cm cubic of gaseous hydrocarbon. Burn it in 120 cm cubic of oxygen, which is in excess. He told you we have excess of oxygen. So, some of oxygen will remain unreacted After cooling, the volume of gaseous remaining was 90 centimeter cubic. The volume of gases not reacted is 90 centimeter cubic. Aqueous sodium hydroxide was added to remove carbon dioxide. 30 centimeter cubic of oxygen unreacted remained. So the excess is 30 centimeter cubic of oxygen remained. All volumes are measured at room temperature and pressure. Explain why it is essential to use excess of oxygen. If you studied organic chemistry, we have two types of burning reaction. The first type of burning reaction is complete burning reaction. In complete burning reaction, we will react the substance with excess of oxygen to form carbon dioxide and water. Second one, incomplete burning reaction in insufficient oxygen. We will react our hydrocarbon plus oxygen to form carbon monoxide plus water. So, we must have excess of oxygen to have complete burning reaction. As complete burning reaction will form carbon dioxide and water. Next question. Carbon dioxide is slightly soluble in water. Why does it dissolve readily in alkaline solution of sodium hydroxide? Sodium hydroxide is an alkali. It is alkaline solution. Carbon dioxide, it is acidic solution. So we will have reaction between acid and base to form salt and water. Just we can say that carbon dioxide is non-metal oxide. It is acidic oxide. Sodium hydroxide is an alkali. Acid plus alkali will form salt plus water. Neutralization reaction, we studied it in acid and base reaction. If you can't memorize the reactions, turn back to acid and bases. So we have carbon dioxide plus sodium hydroxide will form sodium carbonate plus water. But in the case of water, water is just neutral oxide. It is neutral solution. Okay? Okay. Next question. Calculate the following. Volume of gaseous hydrocarbon, he said we start with 20 centimeter cubic of hydrocarbon. It is given. Volume of oxygen used, we said that we start with 120 and after the reaction the remaining of oxygen is 30. So used amount of oxygen is 90 centimeter cubic. Volume of carbon dioxide formed inside our reaction. We have remaining gaseous is 90 centimeter cubic. Remaining gaseous unreacted. Remaining gaseous after the reaction included unreacted oxygen and carbon dioxide forming. Unreacted oxygen is 30. So we have 90 remaining gases minus 30. 30, it is the volume of oxygen produced. 90 minus 30 equals 60 centimeter cubic. Next question. Use the above volumes ratio to find the mole ratio in the equation below and hence find the formula of hydrocarbon. CxHy plus O2 will form carbon dioxide plus water. At first, we start the reaction with 20 centimeter cubics of hydrocarbons. It will react with 90 centimeter cubic of oxygen to form 60 centimeter cubic of carbon dioxide. All of these are gases, and all of gases volume at room temperature is the same. So if we expect that 20 centimeter cubic equal to, for example, 1 mole or 1 unit. Number of moles of oxygen, 90, is 4.5 moles of oxygen. 4.5 times 20 equal 90. 60 carbon dioxide, it is 3 moles. 3 times 20 equals 60. So we can say that each 1 mole of hydrocarbon will react with 4.5 moles of oxygen to form 3 moles of carbon dioxide. We still want to balance number of hydrogen and oxygen atoms. Already hydrogen we don't know it, but we can balance number of oxygen atoms. We have 4.5 O2, we have 9 atoms of oxygen. 3 times 2, we have 6 atoms of oxygen. So we still have 3. We can add 3 H2O. So we have 3 water molecules. To know the formula of our hydrocarbon, we can say that number of carbon atoms in products are 3. Number of hydrogens, 3 times 2 equals 6. So we can say we have C3H6. It is the formula of our hydrocarbon. Next one. The equation below shows how the fertilizers ammonium sulfate is manufactured. 2 molecules of ammonia will react with 1 molecule of sulfuric acid to form ammonium sulfate. In the following reaction, write a word equation for this reaction. Just ammonia plus sulfuric acid will form ammonium sulfate. How many hydrogen atoms are there in the formula of ammonium sulfate? It is given for us the equation, so just we have 4 hydrogen atoms between brackets, so it is 4 times 2. So we have 8 hydrogen atoms. Next one. What is the formula mass of sulfuric acid? The formula mass, or the relative molecular mass of sulfuric acid, Mr for sulfuric acid. Relative molecular mass for H2SO4, we have 2 hydrogen atoms. 2 times relative atomic mass of hydrogen. 2 times Ar for hydrogen plus Ar for sulfur plus 4 times Ar of oxygen. So we can calculate it. 2 times 1 for hydrogen, 32 for sulfur, 4 times 16 for oxygen. So we have 98. Next one. In this reaction, 17 grams of ammonia produce 33 grams of ammonium sulfate. What mass would produce 3.4 grams of ammonia produced? So we can say if we start the reaction with 17 grams ammonia, we will have 33 grams ammonium sulfate. If we start the reaction with 3.4 grams ammonia, how many grams of ammonium sulfate will be produced? This equation and this question can be repeated for you in tons. Just the same. By using cross multiplication, it is not the only question in this part. He can tell you in one of the industries for making fertilizers, we start to add 17 tons of ammonia to form 33 tons of ammonium sulfate. If we add 3.4 tons of ammonia, how many tons of ammonium sulfate will produce? By using cross multiplication to calculate the mass of ammonium sulfate produced, 3.4 times 33 divided by 17 equal 6.6 grams. It is the mass of ammonium sulfate produced. Next question. A 5 grams sample of impure lead nitrate. So he told me from the first we have impure lead nitrate. So it is in excess. We won't use all the 5 grams. The volume of oxygen formed after the reaction is 0.16 decimeter cubic, measured at room temperature and pressure. The impurities didn't decompose. Calculate the percentage of lead nitrate in the sample. At first we have lead nitrate. Each 2 moles of lead nitrate will produce 2 moles of lead oxide plus 4 moles of nitrogen dioxide plus 1 mole of oxygen. At first, he starts to tell me calculate number of moles of oxygen formed. Number of moles of oxygen formed as we have volume, number of moles N equal given volume by the molar volume. So we can say that it is 0.16 over 24 decimeter cubic. So our number moles equal volume divided by molar volume. 0.116 divided by 24 or 0.0066 mole. Next one. Number of moles of lead nitrate in the sample. Number of moles of lead nitrate in the sample. We have mass and we want to calculate number of moles. Number of moles N equal mass over relative molecular mass. So, if we want to calculate in the sample, we will use the following relation. If we want to calculate number of moles of lead nitrate in the sample used in the following reaction, so just from the calculated number of moles of oxygen, we will calculate number of moles of lead nitrate. So each 2 moles of lead nitrate will produce 1 mole of oxygen. Number of moles of lead nitrate is 2 times 0.0066 will form 0.0133 mole. It is the number of moles of lead nitrate we must use in the reaction. Mass of 1 mole of lead nitrate is 331 grams. The mass of lead nitrate in the sample. The mass of lead nitrate in the impure sample. Number moles N equal mass over relative molecular mass. We want to calculate N, number of moles. We have mass of 0.133 times 331. So we have 4.413 grams are used in the reaction. So from the 5 grams of the sample, we use only 4.4 in the reaction. Why 4.4 in the reaction? Because it is the mass of the reacted moles. In the reaction, each number of moles of the oxygen produced from 2 moles of lead nitrate. This amount of moles of oxygen is, in the other hand, equal to 0.133 moles of lead nitrate. So the mass of the following number of moles is 4.413 grams. So we have excess, we have extra of lead nitrate. We have mass of lead nitrate not involved in the reaction. So we want to calculate the percentage of lead nitrate in sample. Equal pure sample divided by total mass of impure sample times 100. 4.413 divided by 5 times 100 equal 88.266. At first, be sure if your percentage yield is more than 100, you are wrong. If in your calculation the mass of reacted is extra the mass of given sample, you are wrong. So just start to study your equation step by step. Next example. Quantities of chemicals expressed in moles. can be used to find the formula of compound to establish an equation and determine the reacting masses. Compound containing 72 magnesium and 28% nitrogen. What is the empirical formula? In the last session, in the last video, we calculated the empirical formula and we said the empirical formula is the simplest formula that indicates the ratio of each element in your compound. For example, we say if we have in our example the mass of each element or the percentage of each element, just divide the given mass or percentage by the relative atomic mass of the element. We have 72% magnesium, 28% nitrogen, and we know that magnesium Mg is 1224. So the relative atomic mass of magnesium is 24. Nitrogen N 714. So the relative atomic mass of nitrogen is 14. So we have 72% of magnesium divided by AR of magnesium 24. We have 28% of nitrogen divided by relative atomic mass of nitrogen is 14. So we have 3 to 2 relation. In our compound magnesium Mg3N2, so each 3 magnesium atoms reacted with 2 nitrogen atoms. So we can write the empirical formula of our compound Mg3N2. The next example. Compounds contains only aluminium and carbon. 0.03 moles of this compound reacted with excess of water to form 0.112 moles of aluminium hydroxide and 0.09 moles of methane. Write a balanced equation for this reaction. To write the balanced equation, we have compound reacted unknown, and we have known values, known number of moles of reactants and known number of moles of products. So we have aluminium and carbon reacted with excess of water to form aluminium hydroxide and methane. Number of moles of our compound 0.03 mole will react with water to have 0.12 mole of aluminium hydroxide and 0.09 mole of methane. In our reaction, we have different number of moles. We just want to make relation between the given number of moles. In our reaction, each 1 mole of compound will react with water to form. We can write 0.112 is 4 times 0.03. Of course, we can. So we have 4 moles of aluminium hydroxide. We can write 0.09 3 times 0.03. Of course, we can. Plus 3 moles of methane. So our compound AlC plus excess of water will form 4 aluminium hydroxide plus 3 methane molecules. Our compound Al4C3. Why Al4C3? Just from the balance of the equation, we have 4 aluminium atoms, we have 1 aluminium atom. So we have Al4. Our compound is unknown, so it is allowed to change the structure of the compound. We have 3 carbon atoms, so we have Al4C3. Excess of water will form 4 aluminium hydroxide plus 3 methane. We can balance number of water molecules. We can balance the excess of water molecules. We have 4 times 3 hydrogen atoms. We have 12 hydrogen atoms. 3 times 4, we have 12 hydrogen atoms. So we have 24 hydrogen atoms. On the other part, we have 2 hydrogen atoms. 2 times 12 equal 24. We must have equal number of oxygen, 12 oxygen. On the other part, 3 oxygen times 4, we have 12 oxygen. So we have equal number of oxygen atoms. In the last question, we have bromine molecule, 0.07 moles of silicon react with 25 grams of bromine. Silicon plus 2 bromine molecules, 2Br2, will form SiPr2. Which one is the limiting reagent? Explain your choice. We say that the limiting reagent is the reactant which ends the reaction in small amount. Is the reactants which will finish at first. Is the reactants in a small quantity. We said, for example, we have community contains females and males. Our females are 50. Our males are 40. To have new families, to have new couples, of course, we will just have 40 new families. We will have 40 couples. And we still have 10 excess females are single. 10 excess females are not included in forming new families. So we have 40 couples and 10 are excess. So our limiting reagents are the male number. The same in the chemical reaction. We want to know which one in excess and which one in low concentration. Number of moles of silicon is calculated 0.07. So we just want to calculate number of moles of bromine. To calculate number of moles of bromine, number of moles equal mass over relative molecular mass. Our mass is 25. Relative molecular mass of bromine is 79.9, it is nearly 80. Bromine is gas molecule, it is Br2. So its relative molecular mass is 80 plus 80 equal 160. 25 over 160 equal 0.156. According to the equation, each 1 mole of silicon will react with 2 moles of bromine to form 1 mole of SiPr4. From the reaction, if we start with 0.07 mole of silicon, it will react with 0.14 of bromine. Already we have 0.156, so we have excess of bromine. Excess of bromine is 0.016. It won't include it in the reaction. They are unreacted. And of course, in the reaction, silicon is the limiting reagent. So we have finished this part. How many moles of silicon bromide are formed? The number of moles of products, of course, equals the number of moles of the limiting reagent. Number of moles of families equals the number of moles of males equal 40. So number of moles of silicon bromide equal number of moles of silicon equal 0.07 mole. So we have finished these examples. We have finished our IGCSE questions. I hope you understand it well. If you can't memorize it from the first time, start to repeat the video again. Start to see the question and try to solve it by yourself, step by step. These equations are very valuable. These equations are very important in quantitative chemistry. You must train it if you are a GCSE student. If you are a S student, you must train the following equations. In the next lesson, inshallah, we will meet together in chemical analysis, and investigations of cations and anions. I hope you understand our lesson today. Don't forget to give us like and share, and don't forget to make subscribe to have any new video in our channel. Thanks for watching. See you later. Assalamu alaikum warahmatullahi wabarakatuh.